Hello, my friends. Thank you very much for subscribing to our channel. Today let's continue to discuss a new question with this pyramid structure. Yesterday we discussed a question about large pyramids. The large pyramid is composed of many small pyramids, except for the uppermost and lowermost layers. Each ball in each layer is the top vortex of a certain small pyramid, and is also one of the three balls of another small pyramid. In addition, the distribution of balls of each layer is always an equilateral triangle. Now, today's question. We remove the last requirement, so the distribution of balls of each layer no longer has to be an equilateral triangle. So, can other towers be constructed with the sum balls? Please give an example, and calculate how many balls are needed for a 5-layer tower? The answer is yes. So let's take a look at how to construct a new tower. We start from a certain layer of balls, and packet these balls together. In fact, the centers of these balls are all on the nodes of a triangular lattice. The balls on the upper layer need to be placed in the center of 3 adjacent balls on this layer, but these central positions are the nodes of a hexagonal lattice. And the arrangement of the balls in each layer is the same, so the center of the balls in the upper layer should also be on the nodes of a triangular lattice. There are two options for choosing a triangular lattice from this hexagonal lattice. One is the red points, and the other is the blue points. For the upper layer, there is no essential difference between choosing the red points or blue points. For example, we now place them on the red points. What really makes the difference is the further next layer. We can certainly put them on the blue points now. This combination brings the large pyramid we discussed yesterday. But at this time, the blue points are not the only option, because the black points are also in the center of the 3 adjacent balls. So we can also place the new layer of balls over there. If we do so, we won't get the large pyramid like yesterday. Let's look at the difference between these two cases from another angle. It doesn't make any difference if we only look at one layer. The upper layer will not make difference either. Going up another more layers, we will find the real difference. Of the structures discussed yesterday, it is easy to see large pyramids with more than 2 layers. Whereas in the structure discussed today, the balls of the 3rd layer and the 1st layer are aligned vertically. In the structure discussed yesterday, the balls on the 4th layer are aligned with the 1st layer. So in the vertical direction, it has a period of 3 layers. In the structure discussed today, the 4th layer and the 2nd layer are aligned, and its period has 2 layers. Of course, we can also discuss the combination of the two structures. But then, there wouldn't be many interesting patterns to speak of. So back to such a relatively simple structure. If this tower has 5 layers, how many balls are there? The first 2 layers are the same as that discussed yesterday. For the 3rd layer, we need a ball in the center, so there are 7 in total. And there are 11 balls in the first 3 layers. The center of the 4th layer needs to be the same as the 2nd layer, with 3 balls. The surrounding area needs 9, a total of 12. So there are 23 in the first 4 layers. The center of the 5th layer is the same as the 3rd layer. There are 12 balls around, and 19 in total. So 42 balls in the 5-layer tower. In the next 2 videos, we will discuss the general term formula for the number of balls in these 2 towers respectively. For now, thank you very much for watching, and see you next time.